All right, let's talk about some ambiguous cases. And this is one of the harder concepts to understand, so just hang in there. I'm going to try to explain it the best way I know how. And these cases are only if you're given two sides and an angle where the angle's not included. You use the law of sines for that. But the kicker to that is if you're given two sides and an angle, there could be 0 triangles, there could be 1 triangle, or there could be 2 triangles. So we need to look at each case so I can explain to you how that's even possible. So the first case we're going to look at is case 1, and that's 0 triangles. So in this first example, I've already got the triangle drawn, but let's label it. So make sure you draw and label your triangles. So side A is 20, side C is 45, and then they've given me angle A is 125 degrees. Now hopefully right off the bat you can see that there's no triangle possible here because of the fact that angle A is 125 degrees. One important thing that's going to carry out through this whole thing is you can only have at most one obtuse angle in a triangle, and that should make sense to you, right? If you have an angle, an obtuse angle, an angle over 90 degrees, the other two angles have to be acute. They have to be less than 90 degrees, because if you had two obtuse angles, two angles that were over 90 degrees, that would blow up the triangle, right? You can only have 180 degrees in a triangle. So at most, one obtuse triangle. We've got an obtuse triangle, I keep saying triangle, I mean an angle. All right, we've got an obtuse angle here. And the other thing we know is that the biggest side has to be across from the biggest angle. Well, if you notice, what they gave me that the side across from the biggest angle is 20, and then they gave me this side length of 45. Well, that can't be possible because our biggest side has to be across from our biggest angle. So there's no triangle here. All right, so that's one example of that. Another example, they've given me two sides and an angle where it's not included, so I'm going to label this again. We've got 50, 100, and A is 50. So this may be not so obvious when you just look at it that this isn't going to be a triangle, but if I went ahead and set this up to solve it, so the information that I'm given is I'm given the A ratio for my law of sine. So I've got the sine of 50 over 50 has to equal the sine of B over 100. All right, and if I just continue solving this and I cross multiply and then isolate the sine of B, I get that the sine of B, I'm looking for that angle, is 100 times the sine of 50 degrees all over 50. All right, remember that when I'm looking for an angle, I'm going to use my inverse function. So the inverse sine of 100 times sine of 50 over 50. Now, if you just go straight into your calculator and use your calculator, you're going to get an error, a domain error. All right, but I want to tell you why this is, other than the fact, and you're like, oh, maybe you just punched the numbers in wrong. No, because this value right here, if you just plug that in your calculator, you're going to get about 1.53. All right, so what this is asking for is the sine of what angle is 1.53. Well, you may or may not remember when we talked about inverse functions and I was talking about the domain and the range. The range, the output for our sine cosine function, it has to be between -1 and 1. Well, this is bigger than 1, so this is not possible. All right, so there's no triangle in this one either. All right, and I'm just going to keep going here. All right, so let's look at our second case. Our second case is 1 triangle. So that was 0 triangles. Now we're going to look at the case of having one triangle. Okay, so labeling here, I've got A is 110 degrees. I've got B is 15. I've got side A is 28. All right, so let's set this up. Now, hopefully you can look at this. I have my A ratio. I have side A, and I've got angle A. I've got side B, which means I have to find angle B first. All right, so I don't have a choice here. I've got to solve for B. So I've got sine B over 15 equals sine A over 28. All right, when I solve this, I get 28 times the sine of B equals 15 times the sine of 110. All right, isolating B by dividing by 28. Okay, I'm going to get the sine of B equals 15 times the sine of 110 over 28, which means I'm going to take the inverse of that to find what this angle is. All right, when I punch that in my calculator and do all that, I see that angle B is approximately 30 degrees. It's just approximately 30 degrees. All right, now let me explain to you why we only have one triangle here. All right, and maybe it'll become more clear when I show you why we would have two triangles. But the reason that we only have one triangle here is because of what I was talking about with this obtuse angle thing. I have an obtuse angle here, right? Which means I can have at most one obtuse angle. Okay, which means when I find this angle B, since we're talking about the sine function, that means that, remember, for the sine function, our exact values were positive in quadrant 1, but they're also positive in quadrant 2. So sine is positive in quadrants 1 and 2, which means really my angle could be in quadrant 1, or maybe it could be in quadrant 2. However, in this case, it can't be in quadrant 2, because if it were in quadrant 2, that would mean it's obtuse. Well, I already have my obtuse angle, so the only choice I have here is for B to be 30 degrees. All right, so this is only going to make one triangle. And at that point, once you've got that 30 degrees and determined that that's the only thing it can be, you just finish solving out the triangle. So if A is 110, B is 30, that means C is 180 minus both of those. So C is going to be 40 degrees. Once you've got that, you can find side C. You find side C by setting up your ratio. So we know the sine of C, which is 40 over little c, that's what we're looking for here, has got to equal, and I would use what they gave me because this was an approximation, and if you use the number that you already approximated, it's going to throw your decimals off. It's not going to be incorrect, but it's going to throw your decimals off enough to where you don't want that, because WebAssign might freak out about it. All right, so we want to use what we're given, so we're going to use the sine of 110 over 28, and you're going to cross multiply, and we're going to find that C, I'm not going to write that out because you already know how to do that. We've got C equals about 19. All right, so this was the case. We've solved the triangle, and this was case 2 when we only had one triangle. All right, so I solved that. 3 sides, 3 angles. All right, let's go on to the last case. So the last case is 2 triangles. How are we possibly going to get 2 triangles out of this thing? All right, so let's look at this. We've got side A is 30. We've got side C is 40. And angle A is 37 degrees. All right, what angle do you have to solve for here? Pause. I hope you said angle C, because I've got my A's, so I've got the sine of 37 degrees over 30. has to equal the sine of C over 40. And when I cross multiply, I hope we all are, at this point, good with that. We've got, I guess I'll write it out one more time. I divide by 30 and take the inverse of all that. I see that angle C is about 53.4 degrees. All right, so we've got 53.4 degrees. All right, so here's where the ambiguity comes in. So this is what I was talking about when we just did one triangle. Remember in this triangle up here, we had an obtuse angle. So I knew that this angle had to be acute. All right, in this triangle that I'm doing right now, I find an angle that's an acute angle, but this other angle is an acute angle. So actually, I don't know, that angle came out of quadrant 1, it's an acute angle. I really don't know if this is the angle from quadrant 1, or it could possibly be the angle from quadrant 2, okay? Remember that a sine of 30 degrees is 1/2. That the sine of 150 degrees is 1/2, right? This is quadrant 1, this is quadrant 2. In other words, if I said, hey, what angle of sine gives you 1/2? Well, yeah, it's 30 degrees, but couldn't it also be 150 degrees? Yeah, it could be. That's what this ambiguity is doing. It's saying that 53.4 is a possibility, but so is the angle out of quadrant 2. All right, to find the angle out of quadrant 2, how do we do that? To find the angle out of quadrant 2, we just take 180. Right, we're always going from the x-axis, right? That would be my reference angle. So I would do 53.4 would be my reference angle. So I subtract 53.4 degrees to get that angle out of the second quadrant, and that angle out of the second quadrant would be 126.6 degrees. All right, so that is also a possibility. And if I were you, I wouldn't try to keep track of it, because when you start setting up your ratios, you might get the numbers confused. Once you realize that there's a possibility of another triangle, go ahead and draw another triangle. All right, so I'm going to draw another triangle, and I'm going to label it. Now, the labeling part, the given, what they gave me in the original problem, that cannot change. All right, I still know, let's do A, B, and C. So I still know that A is 37 degrees, that was given. I still know that side C is 40. I still know that side A is 30. That's not going to change. The only thing that's changing in this triangle is that C could have also been 126.6 degrees. All right, so now really what I have is two triangles, and I have to finish solving them. All right, and that's just going through the process of what you already know how to do. In this, let's do the first triangle, for example. That first triangle, I've got angle A, I've got angle C. To find angle B, I would just subtract from 180, and I would get 89.6 degrees. All right, so the last thing I need to do to solve that first triangle is to find side B. So I'm going to use what they gave me with A, not what I've approximated. So I'm going to use the fact that I know that the sine of 37 over 30 has to equal the sine of B, which in this case is 89.6 divided by my unknown. All right, and when you cross multiply there, I'm not going to work it out for you, but when you cross multiply there, go ahead and cross multiply and then make sure your answer checks out. You should get side B to be approximately 49.8. All right, so that's solving that first triangle, the first possibility of that triangle. Now just going on, separate triangle. I created a whole nother triangle with the angle from quadrant 2 as my possibility. So when I subtract those two angles from 180 to get angle B, I get angle B is 16.4 degrees. Right? I set up my proportion, so I've got the sine of 37 over 30 equals the sine of that B value now, which is 16.4 over B. Cross multiply, do the calculation, and B is approximately 14.1. Okay, so that's the 3 cases for the ambiguous cases, given 2 sides and an angle that's not included using the law of sines. I worked another ambiguous case in Canvas. If you're not in Canvas right now, and this video is not in Canvas, so you're not in Canvas right now, go back and watch another example worked in Canvas.